So the next section we're going to take a look at is 3.4. 3.4 is on what we call synthetic division and the rational root theorem. First thing about this is in our book, they refer to synthetic division as Horner's algorithm. So if you see that phrase and they say like use Horner's algorithm to solve the problem, it means use synthetic division. Okay, so just clear that up right away. All right, when we're looking for where our graph crosses the x-axis, right? We're looking for the roots. The roots, or the zeros, can cross the x-axis at rational spots and irrational spots. What does it mean if a number is rational? Remember, what does rational mean? Yep.
This is where it's 2 points that on the y x-axis that whether it be positive or negative, it's
so it doesn't have anything to do with graphing necessarily. It just has to do with the kind of number that it is. We looked at this way at the beginning of the year. Rational number. What does it mean if a number is rational? Oh, Connor, you remember?
Is it a real number?
No, real number is a little bit bigger. That includes more kinds of numbers. Rational is a little bit more restrictive than real.
Is it to be a constant?
Well, all numbers are constants. So every number is a constant, but it's a certain kind of constant, a certain kind of number. Yeah?
A number that can be written as a fraction.
A number that can be written as a fraction. So irrational numbers are numbers that cannot be written as a fraction. So we're going to look at a theorem that will help you to figure out if a graph is going to cross at a number that can be written as a fraction, what would be the fraction? This theorem is going to help us figure that out. Now, for quadratics, we don't need a theorem. We already have a theorem. Right? Or we already have a formula, quadratic formula. Quadratic formula can find where it crosses the x-axis for you. But what if we don't have a quadratic? What if we have a fifth degree polynomial? Well, how are you going to figure out where it could cross the x-axis? That's what this theorem will help you do. Okay. So, let's start by looking at this. This represents a polynomial. When we do an actual problem, they'll have numbers like that. But we're going to start with the highest exponent, and it's going to keep dropping down until finally we don't have a variable left, and all we have is a constant. So that's what this represents. Exponent going down. The numbers in front, oops, these are the coefficients of x. So in the next problem we're going to do, they're going to be a 10, a -3, and a 1. And then the very last number is going to be a -6. Right over there. So let's say we have a polynomial like that, and we want to figure out anywhere that it could cross the x-axis at a number that's rational, a number you could write as a fraction. Well, in order to use the theorem I'm about to show you, all of these numbers in front have to be rational. And for every problem I give you, they will be. But there are two restrictions. This number and the last number cannot be 0. If there's 0, then this theorem doesn't work. But every problem that I give you, and I ask you to do rational root theorem on, will fit that condition. It will work. Okay, so if a number can be written as a fraction, it has a numerator and it has a denominator. In the fractions that I'm about to write, I'm going to call the numerator p, and I'm going to call the denominator q. if you have a graph that is going to cross the x-axis at a number that can be written as a fraction, then the numerator will have to be a factor of the constant. The constant is the number at the end, without a variable. So the numerator has to be a factor of the constant. Again, if you're going to cross the x-axis at a rational spot, the denominator of your fraction would have to be a factor of the leading coefficient. So then, to do this whole theorem, there's really only two numbers you need to look at. You need to look at the constant, which is right here, and you need to look at the leading coefficient, which is right there. None of the other numbers in the middle are used in this theorem. They're not used. So what this theorem is going to do is it doesn't actually give you a definite answer. What the theorem does is it gives you a list of fractions that could be the answer. And it is possible that none of them are. But that's all that this theorem does, is it gives you kind of a starting point. It gives you a bunch of fractions to look at and says, if this graph crosses the x-axis at a fraction, it will be one of the numbers in this list, if it even crosses at a fraction. Okay. So we're going to get a list, and not every number in the list is going to be a 0. There might be one in the list. There might not even be one. Depends. But what we want to do to start is just practice generating the list. And just think of the list as a bunch of fractions that are like a starting point, and then we'll go from there. So here's our polynomial. And I want to list all possible rational roots, all possible rational zeros. Okay, so the first step is to generate all the different p-values, which go in the numerator, and q-values, which go in the denominator. Start with p. P are all the factors of the constant. What is my constant in this case?
-6.
-6. What are all the factors of -6? Yeah?
2 and 3.
2 and 3.
6 and 1.
6 and 1. That's half of them. What else?
They're negatives.
And they're negatives, yes. So we have positive or negative 1, 2, 3, 6. Those are all the factors of P. Q. Q are all the factors of the leading coefficient. What is the leading coefficient?
10.
10. What are all the factors of 10?
Positive or negative, 1, 2, 5, and 10.
Yep, perfect. Positive or negative 1, 2, 5, and 10. So now, if this graph crosses the x-axis at a fraction, it's going to have one of these numbers in the top of the fraction and one of these numbers in the bottom. Now I need to write all those possibilities out. It's not hard as long as you do it kind of organized. So let's write down all the different p's over all the different q's. So the way I would do it, start with a p and do that over every q. So 1 over 1, 1 over 2, 1 over 5, and 1 over 10. Those are all the different possible rational roots with a 1 in the denominator. Which one of them works, if any? I don't know that yet. That's not what this theorem tells me. It just gives me a list of things to further investigate. Right. Next one we want to do is with a 2 in the top. What would be my first root with 2 in the top? 2 over 1. Yeah.
Just 2.
Yeah, so 2 over 1, which is just 2. What would be the next one to try? 2 over 2, but
That's just 1.
that's just 1. So you do get a lot of repeats when you do this. We already got that one. What would be the next one to try?
2 over 5.
2 over 5, we don't have that one. And the last one with 2? Yeah,
2 over 10.
2 over 10. But yeah, we already have that one. That's 1/5. Yep. Okay, so let's do the 3 in the top. We don't have any with 3 in the top yet. So 3 over 1, 3 over 2, 3 over 5, and 3 over 10. So those are all the fractions with a 3 in the top, and now with a 6 in the top. What's my first one with a 6 in the top? Yep, 6 over 1, which is just 6. Next one I would try would be, wait. So we got 6 over 1, now we want to do 6 over
6 over 2.
6 over 2, but what's that?
3.
3, we've already got 3, so we can skip that one. Royston, the next one after 6 over 2?
6 over 5.
6 over 5, we don't have that. And the last, Nadia, the last one?
6 over 10.
6 over 10, but what's that? 3/5, we already got it. Okay. So this is what we call our list of possible rational roots. If, and again, this is still
Possible rational what?
possible rational roots. Okay, and this is still an if. If this is going to cross the x-axis at a spot that's a fraction, it has to be one of these numbers. It cannot be anything else. If it crosses at a nice number that you can write as a fraction. Okay, so now let's see if we can narrow down the numbers in that list by looking at a picture of the graph.
It said possible rational roots.
Yep, that's the possible rational roots. And we're going to narrow that list down. So we've got 10x to the 5th minus 3x squared plus x minus 6. So once that graphs, we're going to cross out ones that don't even look close. Okay, so there is our graph. Let's start with -1. Does it look like that graph crosses at -1? No, so we're going to get rid of that. +1?
Yeah.
Maybe, yeah. That's one we could check out a little further. How about positive or -1/2? Do we look like we're near any of those?
No.
No. Positive or -1/5?
No.
No. And positive or -1/10? It's 0.1. No. Doesn't look like it's anywhere near those. How about positive or -2? Do either one of those look reasonable? How about positive or -2/5? That's 0.4. No, we're not near 0.4. Positive or -3? No. Positive or -1/2?
No.
No. Positive or -3/5? That's 0.6. Nope. And how about positive or negative 3/10? That's 0.3.
No.
No. Positive or negative 6? Does it look like we crossed the x-axis near there? No. John?
The x-axis?
Yeah.
No.
No. Right? You got to. These are x values. We're nowhere near 6 and negative 6. Negative 6/5. That's negative 1.2. Are we near that? No. How about positive 1.2? Could we be near that? Maybe. I mean, I think 1.2 might be a little bit further over, probably closer to where that red dot is. But, I mean, without zooming in, we wouldn't know for sure, but maybe. I would consider that still reasonable. So now what we have here is the list that's been narrowed down. So that's just called the narrowed down list. Right? Now, let's actually find the root and see what happens. Okay, so I'm going to do second calc, and which option will find the root? Zero. So pick a point to the left, pick a point to the right, do your guess, hit enter, and that is the root, 0.9505. Which number in this list is this? So that's the same number as 1?
No, exactly.
It's got to be exact. Yeah, it can't be close. That is the actual answer. That's the exact answer right there. So which number here matches up with that? None of them. So what was this list again?
Possible roots.
A little bit more? Possible rational roots. That's the real answer. And it's not in this list. So what do you think that means about this number then? Yeah?
It's an irrational.
It's irrational. So the only place that this graph crosses the x-axis is at a number not in this list, which means that has to be an irrational number. This number could not be written as a fraction. If it could, it would have been in this list, and it's not. So let's write that down. So show that it only has one real root and that it is irrational. Okay, so since the root is about, I think it was 0.9505. Okay, so since the root is approximately 0.9505 and 0.9505 is not in the list of possible rational roots, the only other option for it is it has to be irrational. So since the root 0.5 is not in the list of possible rational roots, it must be irrational. Okay.
What is that double sum?
This,
Yeah.
approximately. About. It's not exactly 0.9505, I rounded it. Okay, so we've proven exactly what they wanted us to prove. We've showed that it is irrational. So that's kind of the case we don't want to have. When we use the rational root theorem and we get that list of numbers, we want to have a number in that list that works. We need to have a number that works. So when we do rational root theorem again, we'll have a number that does work. But this time, rational root theorem basically didn't help us at all. Well, the only thing it helped us to do was to show that this number is irrational because it didn't come up in the list. Okay, so any questions on that idea of generating the P's and the Q's from that problem? All right, we'll do another one and we'll have a lot less P over Q's. That's a lot. Okay, that's 8, 9, 10, that's 12 plus all the negatives. That's 24 different numbers we have to look at. But usually there's less than that. All right, so now we're going to look at doing division, but I'm going to show you a faster way to do it than long division. But the downside is it only works some of the time. Okay? It's called synthetic division. And synthetic division works as long as you divide by x minus a number. If it's anything more complicated, like x squared, then you got to go back to what we learned yesterday. So let's take x squared plus 3x minus 5. And we're going to divide that by x minus 4. Okay, and I'm going to do it synthetically. So I'll show you I'll show you the step on the left, and then we'll actually do the step on the right. So the first step is to look at the c value. This is the c value. It's the number after the minus sign. It's just like the remainder theorem. It's just like the remainder theorem. So look at the number, take the x minus, block that part out, and look at what you have left. In this case, it's a 4. Put the 4 on the outside of a bracket, and put all your coefficients on the inside. If you're missing any, just like yesterday, you're going to fill in zeros for all the ones you're missing, but we're not missing any. Okay. What's the coefficient of my x squared term? 1. What's the coefficient of my x term?
3.
And what's my constant? Negative 5. That's how you set up your synthetic division. Okay. The other nice thing about synthetic division, you will not be writing any variables through the whole process. So it's just numbers. Okay, bring down the first coefficient. Just like that. So bring down the 1. Next step. You're going to multiply the divisor, which is my 4, times the number that I just brought down, which is 1. What's 4 times 1 give me? Yeah, 4. And we're going to put that answer in the second column. So we multiplied 4 times 1, we got 4. Put the answer in the second column. Now, big difference between what we learned yesterday and today. Add your columns. Don't subtract. Okay. What's 3 plus 4 give me? Yeah? 7. Okay. So now we're going to keep repeating this process. 1? So we brought the 1 down. We just brought it down. And 4 times 1 is 4, and 3 plus 4 is 7. So now keep repeating steps 3 and 4. What's 4 times 7? Yeah. 28. And add that column up. What's negative 5 plus 28? Have a good afternoon. 23. And that's it. That's a synthetic division problem. Now we just got to interpret that last row, 1, 7, 23, and see what it means. In that last row, the numbers you're looking at are your quotient and your remainder. This is your remainder. That is your quotient. So if you had to write your answer as quotient and remainder, well, remainder is 23. And the quotient is 1x plus 7. This term right here is your constant. This is the coefficient of your x. If you had one here, it would be what goes in front of x squared, then what goes in front of x cubed, what goes in front of x to the 4th, and so on. So you just have to work your way over and write all your variables in. So you don't have any variables while you're doing the process, but at the end, you would want to explain what that quotient means. 1x plus 7. And that's it. That's synthetic division. Yes?
What will be the cases in which synthetic division would work?
Would or wouldn't?
Wouldn't.
Wouldn't. So what do we have to have in the bottom to use synthetic division?
X minus C.
X minus c. Yeah, it's got to be x minus a number. So if I gave you a problem like can't use synthetic division because the denominator is not x minus a number.
Can you go back so I can try the steps for the
Does that make sense why you can't use it?
Yeah.
Okay. So it's got to be an x, and then it has to be a minus, then it has to be a number in the bottom. So that, I mean, that comes up enough times that it is worth having synthetic division. Okay. So the next question, it is worded a little differently, but you're actually doing the same thing. They want you to show that 3/2 is a 0. If 3/2 is a 0, what's another way of saying that? I think we have like 5 of them yesterday. If 3/2 is a 0, it also means, yeah? Yep, it means it's a root. There's another way we said it yesterday, and that's the one I'm looking for. But we did say that one too. Yep?
The factor.
Yes. So if 3/2 is a root, then what would be the factor? Think about what you could plug that into that would give you 0 as an answer. Yep.
X minus 3/2.
Yes. So all these mean the same thing. If 3/2 is a 0, it means it's a root. It means x minus 3/2 is a factor. Nobody said this one, but it also means 3/2 is an x-intercept. But this is the one that's important. So what I'm going to do is I'm going to show that x minus 3/2 is a factor, which then automatically means 3/2 is a 0. Okay? How do I show something as a factor of something else? Even with just regular numbers. So how do you show that something is a factor of something else? Yeah?
You take that number that you're trying to prove it's a factor of and divide it by the number that you have.
Or you divide it into
Yeah.
the number. And what do you hope is going to happen if it's a factor?
It's going to be the one number.
So you're going to do the division, and then what's going to tell you if it's a factor? Once you're done the division. You won't have a remainder. Right. You will have a remainder of 0. So I'm going to divide this into the cubic, and I'm going to hope that I get a remainder of 0, which proves it's a factor, which in turn proves 3/2 is a root. All right. Is this a problem that I could use synthetic division on?
Yes.
Yes, it's x minus a number. Take the number after the minus, put it on the outside. What would be my coefficients on the inside? Yeah.
2, -5, 1, and 3.
Yep, we weren't missing any, so we didn't have to fill in zeros. If we were, then we would have put a 0. Bring down the first coefficient. What's 3 halves times 2?
3.
Yep, 3. Now add that column up. What's negative 5 plus 3? Negative 2. Okay. What's 3 halves times negative 2?
-3.
That's going to give you negative 3, yep. And add that column up. What's 1 plus negative 3? Negative 2, good. And one more time, 3 halves times negative 2. Yep, come on.
-3.
Negative 3. And if we add the last column up, we get
0.
0. Okay. So because I got 0, what does that mean about x minus 3 halves? Yeah. I just proved that x minus 3 halves is a factor. So then what does that mean about 3 halves itself?
It's a rational root.
It's a rational root, yeah. So we proved that 3 halves is a root, or 0, same thing. Yep. Okay, so I'll write that down. So since x minus 3 halves is a factor, because we got remainder 0, 3 halves is a root. So worded a little bit differently, but still just doing a synthetic division problem. Okay, any question on that? Let's try another one. SD, that stands for synthetic division. So use synthetic division to find the quotient and the remainder when we do this problem. Okay. When we do synthetic division, what number would go on the outside of my bracket? Yeah. Not 3 in this case. Negative 3, because we're dividing by x minus 3. Okay, to figure out what goes on the outside, block off the x minus and look at what you have left. Negative 3. Okay. Joel, what about my numbers on the inside? And I'll give you a hint. You need to be careful on this one. Okay, that's my first number.
7.
Mm-hmm. Nope. Negative 11. Negative 11 is going to be in there, but that's going to be the last one. We have a few more we got to put before that. What comes after the 7? Yeah? 0. Yeah. Because you don't have any x squareds. If you forget that 0, well, it's wrong. So don't forget the 0. Now my my last two coefficients. Yeah.
1 and -11.
1 and negative 11. Okay. John, what's my first step?
To multiply the -3, right?
I don't have anything to multiply yet till I have numbers under that line.
To add them.
I don't have any columns yet. I just have a single number, so there's nothing to add right now.
Divide something.
Okay, what's our first step? Look back at the notes.
Bring down the 3.
Bring down the 3. Step 1, or well, after you get it set up properly, bring down the first coefficient. So bring down the 3. Okay. What's my next step? Connor?
Multiply the negative 3 by 3.
Yep. And what does that give you?
Negative 9.
And where do you put it?
You put it at the top of the line, but below the 7.
Yeah. Now we have a column we can add up to then keep repeating the process. Gianna, what's 7 plus negative 9? Yep, negative 2. And now we're going to multiply those together and get 6. Add 0 and 6. Multiply negative 3 times 6. Add 1 and negative 18. And what's negative 3 times negative 17? How much? 51, yeah, 51. Good. And now add up that last column, and what do we get for the last number? 40.
Okay.
So now they did ask to find the quotient and the remainder. So you need to interpret that answer. Okay. Can anybody tell me my quotient? Connor.
It would be 3x cubed minus 2x squared plus 6x minus 17.
Good. So I've got our quotient. What's my remainder? 40. Yep. There you go. There's your answer. Any questions on that? Okay, so if you notice, when you do synthetic division, it takes up a lot less space than long division. Long division kind of just keeps going down and to the right. This is pretty much contained in that one area right there. All right, so let's try this one. So now we're going to put everything together. The rational root theorem with synthetic division. When you have a cubic and you need to solve it for its roots, can you just plug it into quadratic formula, get the 2 answers, and you're all set? Why not? It's a cubic. It's not a quadratic. So the only way that you can work with this problem is to turn the cubic into a quadratic. And the way you do that is with synthetic division. Every time you divide through synthetically, you'll take the problem you started with, like a degree 4, and when you're done, you'll have a degree 3. The degree will go down 1 time every time you do synthetic division. So here you had a degree 3. When you do this one, this is now a quadratic. That's a degree 2. Okay. So in order to do the synthetic division, we need to know what number is going to go on the outside. How do we figure that number out? That's where the rational root theorem comes in. The rational root theorem will generate a list of numbers for you to try. You don't want to try every single one, because imagine doing synthetic division with every single number in that list until you find the right one. And in this case, you realize none of them even work. So what we want to do is what we did here. Make your list, narrow the list down, and then if you have 1 or 2 that you think work, try that one. Okay. We definitely want to narrow the list down before we just start trying. So start with the rational root theorem, use the graphing calculator to narrow the list, and then find one. You have to find one. It's not going to be like the first problem. There has to be one that works, or you're not going to be able to do this problem. Find the one that works, and then do synthetic division. Okay. So let's start with rational root theorem. Okay, list out all your P and Q values. P, factors of the constant. What are all the factors of negative 2? Yeah, Joel. 1 and 2, and what else? Negative 1 and negative 2. Okay, not that many options. Plus or minus 1, plus or minus 2. How about Q? What are all the factors of the leading coefficient? Yeah.
Plus or minus 1.
Right, plus or minus 1. So now, can somebody tell me all the p-values over all the q-values? What are the different options? Yeah.
1 over 1, which is
1 over 1. Anything else?
2 over 1.
2 over 1. That's it. If this graph is going to cross the x-axis at a number that's a fraction, because I could make these fractions if I put them over 1, it's either going to be 1, negative 1, 2, or negative 2. So what I do is I look at the biggest one, positive 2, and the smallest one is negative 2. If I set my window to a standard window on the calculator, I will definitely see everything that could be in this list. Okay. If I had a root here that was like positive or negative 20, well, then I'd have to zoom out a little bit in case the answer was out at one of those numbers. Okay, but this is a pretty small section you got to look at. All right, so let's narrow the list down. X cubed minus 3x minus 2. Now, you probably wouldn't have needed rational root theorem here because these are really nice numbers. Okay? But if you had a rational root of like 5/7, it's rational, but that's not a nice number as a decimal. So there are going to be times when you definitely need to do this. Even though in this time, I think you'll be able to look at the screen and tell which one of these it is, because these are not difficult fractions. Okay, so out of those 4 numbers, I must have typed something wrong. Let me just check it. X cubed minus 3x minus 2. Okay, let's try again. So out of these 4 numbers, do any of them look like spots where the graph crosses the x-axis? Yeah.
positive 2.
Yep, I would say positive 2 could be. And where else?
Negative 1.
Negative 1. If they both work, pick whichever one you want to do synthetic division. If only one of them works, then you have to use that one. So let's do trace negative 1. Yep, that's definitely a root because it gave me 0. Let's try positive 2. Yes, that's also a 0. So now we pick which one do you want to pick? Negative 1 or 2? 2. Okay, so we're going to put a 2 on the outside and do synthetic division with a 2. 1x cubed, 0x squared, minus 3x minus 2. Okay. John, what's my first step?
Bring down the 1.
Good, bring down the 1. Now we can multiply. 2 times 1. And what do we do with these 2 numbers to get the 1 below it? Yeah, add them. 0 plus 2 gives me 2. 2 times 2 gives me 4. Add up 4 and negative 3 and we get how much? 1. Now multiply again. 2 times 1 gives me 2. Add that last column and you get 0. So we've just definitely shown that 2 is a root. got 2. Now, we started with a cubic. What's that now? That's not a cubic anymore.
It's a quadratic.
That's a quadratic. That's 1x squared plus 2x plus 1. Now, you set that equal to 0, and you finish solving it. Okay, but now it's a quadratic, so we can do it. And you won't even need quadratic formula here because that is factorable. How does x squared plus 2x plus 1 factor?
Would be x plus 1.
X plus 1. Okay. And
X plus 1.
x plus 1. So now it should be relatively easy to figure out the 2 numbers we can plug in to get 0. What could you plug in right there to make the first factor 0?
-1.
Yep. And what could you plug in right here to do the second factor?
-1.
Okay, so that's a repeated root. We talked a little about repeated roots yesterday and how they bounce off the axis. That's what's happening at -1. You do not need to write the answer twice. I know you're just writing each answer one time. If you want to tell me this is a repeated root, that's fine. But you don't have to write the answer twice. So any question on that one?
Do we have to say it's repeated, or can we just?
Not unless they specifically ask. If the question did say write the roots and determine if any are repeated, then yeah. If you forgot to say it was repeated, you'll lose some points for that. All right, let's try. These are the last 2, so we'll do this one and then we'll see if we have time for that one. Okay. This problem says find all real zeros. Okay. Can we plug it into quadratic formula, get the answers, and we're good? That's always the first thing. If you can do quadratic formula right away or factor, then you're done. But why no quadratic formula? Yeah,
Because it's not a quadratic.
it's not a quadratic. The only way to turn it into a quadratic is with synthetic division. But I don't just want to start guessing what number I need to divide by. It could be any number. Any fraction. So how do I get a list of possible fractions to try?
You do B over Q.
Yeah, do the P over Q's. That'll give you a list of things you could try. Better than randomly guessing because there's a lot of numbers to randomly guess. Okay, what are the factors of P in this case?
1, 2, -1, 2.
Yep. Not bad, plus or minus 1, plus or minus 2. And what would be the factors of Q? Yeah,
Plus or minus 1 or plus or minus 3.
good. Plus or minus 1, plus or minus 3. Now I need to write all the P's over all the Q's. What would be the different values I could get if I do the P's over the Q's? Yep. Yep, plus or minus 1. Okay, what else?
Plus or minus 2.
Okay, plus or minus 2. What else? Yep,
Plus or minus 2 over 3.
2 over 3. And what else? Yep, plus or minus 1 over 3. That's it. So if this graph is going to cross the x-axis at a fraction, it has to be in that list. Okay, so now let's graph it and see if we can narrow it down. So we've got 3x cubed minus 8x squared plus x plus 2. Zoom 6 is plenty because that gives me negative 10 to 10. I only need negative 2 to 2. It's going to be somewhere in there. Okay. Which answers in that list seem reasonable? Yeah.
2/3.
Yeah, could be 2/3. I would agree with that one. Any other numbers in that list that look reasonable? We don't know if they are, but
Negative 1/3.
I'd say it could be negative 1/3. It definitely looks possible. Now, this one is 2 point something. What do you know about this answer? Since it's not in this list.
It's not rational.
It's not rational. So chances are, because it's not rational, once you turn this into a quadratic, it will not be factorable. You're going to have to use quadratic formula to finish it. If it was rational, then you wouldn't. But it's not going to be. Okay. All right, so let's check negative 1/3. Let's go trace. Type in negative 1/3. And is negative 1/3 a 0?
No.
No, it's not. Okay. That is not a 0. It looks like it could have been, but it's not. So now if 2/3 doesn't work, then we're stuck because we don't have anything to divide by synthetically. But when we check 2/3, it does work. 2/3 is a 0, and that's what we need to divide by. When you divide by 2/3, you'll turn your cubic into a
2.
degree 2, which is a quadratic. Yep. And then we can use quadratic formula. Okay, so let's put 2/3 on the outside. What's going to be the numbers on the inside?
3, 1,
3,
2. Negative 8, 1, 2.
negative 8, 1, 2. Yep. Okay. Bring down the 3. What's 2/3 times 3?
2.
2. Add that up. Negative 8 plus 2 is negative 6. What's negative 6 times 2/3?
Negative 4.
Negative 4, good. 1 plus negative 4 gives me negative 3. And what's 2/3 times negative 3?
Negative 2.
Yep, negative 2. Add that last column, you get 0. We already knew it was going to be 0. That's why we checked it. And now we've definitely proven 2/3 is a root. Okay, so we got the first one. What do I have to set equal to 0 now to get the last two? What's going to be my equation on this left side? Yep.
3x squared minus 6x minus 3.
Yep. So now we're going to solve that. But notice everything here, we can make this smaller by factoring what number out?
3.
Yeah, you don't have to, but you're going to have to reduce it now or reduce it later. So let's reduce it now. So x squared minus 2x minus 1. So now solve this. It's not factorable, so you do have to use quadratic formula. When we solve this, what's A going to be? 1. What's B?
2 or negative 2.
Negative 2. And C? Negative 1. So let's fill that in, and then we'll put our other two answers up in that box. So negative B plus or minus the square root of b squared minus 4 times What letter comes after the 4?
A.
A, so that's 1. And what letter comes after that?
C.
C, which is -1. And what do we divide the whole thing by?
2A.
2a, so 2 times 1. Okay, you're going to be subtracting a negative. Since you're subtracting a negative, you can make that a positive right away. What's 4 times 1 times 1? 4 plus 4. That gives you 2 plus or minus root 8 over 2. And the square root of 8 can be simplified. What's the square root of 8? If you simplify it. Yep.
Would it be 2 root 2?
Yep, 2 root 2. And everything on the outside of the root is divisible by 2. 2 goes into 2 once, and once. Okay, so now you end up with 1 plus or minus the square root of 2. Those are your other 2 roots. Now that you know that, we can check it. Let's see what 1 plus the square root of 2 is. 1 plus square root of 2. It's about 2.414. Let's calculate this root. What do you think this root is going to come out to over here? 2.41, yeah. 2.41. So you might say, well, why didn't we just do second calc 0 to get 2.414? Well, I might ask you for the exact answer. So if I ask for the exact answer, I want you to write 1 plus square root of 2. And how would you ever know that that number is 1 plus the square root of 2? You're not going to be able to memorize all those different decimals you could get. Now, if you do the other one, let's do 1 minus the square root of 2. That better be the other root, negative 0.414. That's the one that we thought was negative a third. Well, it's close, but it's not negative a third. It should be negative 0.414. And that's exactly what we got. Okay, so once you get your exact answers with quadratic formula, you can double check them. But I don't think you'd be able to take that decimal and turn it into that thing with the square root. Not without quadratic formula. Okay, any questions on that? So I'll always give you a root that is rational to make sure you can do synthetic division. Always, you'll always have one that works. That's it. So that's the homework for tonight. We'll go over that tomorrow, and remember that tonight will be the last homework assignment because tomorrow night we're going to do the take-home test. I talked about that yesterday, right? Yep. So that'll be tomorrow night. That'll open probably at 2:40, and it will stay open until Thursday at probably 8 a.m. If you don't get it done, it will be a 0, and there won't be any making it up. Okay, so if you don't think you can do it at home, that's fine, but let's plan a time that you can do it in class instead. Just come talk to me and we'll figure that out.